I've just been reading this latest MIT Technology Review report, which was sponsored by Databricks and built off some surveys and assessments that were run through the summer of 2023. The authors interviewed and assessed 600 technology executives in senior roles, including CIOs, CTOs, and people in a data or AI leadership position. And then also a number of deeper interviews with senior executives at some large organizations, including Starbucks, Dell, and General Motors. And there's a couple of insights that I thought would be useful to share with you. But before I go into that, it's always a good reminder, as much for me as for anyone else, just to get that high-level definition of what AI is. Because AI, artificial intelligence, is a buzzword of the day, and everyone is attaching AI to everything. Your stationery supplier is probably going to sell you an AI-enabled pencil before you know what has happened. So AI really encompasses three main things. The first is to perceive a large amount of data, whether that is structured or unstructured, across multiple different sources. So there is a large amount of data in different sources. The second thing is to synthesize all that data and bring it together into a single set of data on which workloads can be run. And then the third part is to actually infer something from that. So having taken all of this data, brought it together, then what is it that we can learn and infer from that to base new decisions? Now, in generative AI, what we're inferring is the next word that we're going to write. But we can also do things in terms of inferring when machines are most likely to break, what the weather is going to be in the future, or how long it's going to take for a certain shipment to arrive on a certain factory. So that's AI, perceiving, synthesizing, and inferring. And when we think about what's the difference between AI and machine learning at a high level is taking that inference, that output, and feeding that back into the start of the process so that the artificial intelligence model continues to get more and more intelligent. Now, when we think about the modern data stack and how does all of the technology that we're using feed into this AI model, I find this diagram useful to start from the left, where we're bringing in different types of data, either first-party data, which is our own data that comes from our own systems. That could be from our own customer data, our product data, or what our own employees are doing. Second-party data, which comes from our partners. Now, that could be traditional partners in terms of business partners, but it could be people further up in our supply chain, our suppliers, or indeed downstream in terms of our customers or our customers' customers. And then third-party data, which is data that we're buying in from other sources. So that could be from data providers, economic data, financial data, currency data, commodity price data, weather data, and so on. So all of those data sources plug into one or other of our applications, our databases, or event streams coming in from sensors in our network, maybe IoT products and platforms. That huge range of data that has been perceived then needs to be synthesized, and that is where that is being integrated, potentially transformed and migrated into large-scale data storage platforms. Now, these may be called data warehouses, data lakes, or somewhere in between, the data lake house, which is gaining a lot of popularity at the moment. And you'll come across products like a Snowflake, which is more of a data warehouse background, Databricks, which is more a data lake house background, and so on. And this amalgamates all of that data centrally. And then over on the right, we got how are we going to use that data, either in more traditional analytics or visualization tools like a Tableau, or as we're talking about here, using some powerful data science, AI, or machine learning analysis and algorithms on this data to be able to pull out these inferences. So over on the left, we've got perceiving the data. In the middle, we've got synthesizing that data. And over on the right, we've got inferring something from that data. Now we get into the Databricks sponsored report from MIT, and a few of graphics that I'll sort of pull out that I thought were relevant. This is a comment from John Roos, the global CTO at Dell, and he talks about there being three main challenges that he sees in this transformation into the world of AI. So one is feeding huge volumes of unstructured data in to train these models. And I think the key thing here is this move from a world where we had or tried to have fairly structured data into a world where the vast majority of data that we're capturing is unstructured. It's coming in through video, it's coming in through sensors, it's coming in through audio, and it's coming in at increasing volumes. And 90% of all of the world's data was created in the last 2 years, and 80% of that is unstructured. So that is very much the new paradigm. The second challenge he perceives is storing that data in a long-term way that is going to be conducive to AI models consuming that data in the future. So we think about bringing all of this data together, synthesizing it and getting rid of silos, and how are we going to do that at scale. And then the third main challenge that he sees when we start thinking about the different AI models, and people are using a large volume of models, as we'll take a look at in a moment. How do we maintain security around those models as multiple different platforms, providers, and indeed startups are starting to run processes and AI models onto our different data sources? This was an interesting graphic that I thought which really brought to life this new world of unstructured and streaming data being the priority. The question here to these senior executives is, in the next 2 years, how important are the following to achieving your organization's overall technology goals? And looking at the percentage of people that responded, very important. And up at the top here, we've got streaming data workloads in a real-time analytics. And it's that real time. We want to know exactly what's happening right now so that we can infer something from that and turn that into new business models, new revenue streams, new products that we can sell out to our customers or our downstream distribution channels. So it is really about accelerating the insights that we can drive from this data. I mentioned earlier about this proliferation of data and AI systems. So what this graphic here is showing is how many different AI and ML systems does your organization use. Now, this is not necessarily saying how many different large language models are you using, but it's the different parts of the stack. And you can see that the light blue graph, which is looking across all respondents, at 29%, so nearly a third of companies are using between 10 and 20 different products already. And this is likely because of potentially the complexity of large-scale organizations, that different business units, different functions are pulling in their own tools. And as a centralized IT function, someone's going to have to consolidate that and bring that together. This is an interesting graphic which talks about, by different industries, what are the top generative AI use cases. So as a reminder, generative AI is using this AI to infer text. It could be code, it could be audio, it could be images. It's creating something based on the large data set that it's looking at. If we look at manufacturing, for example, when we think about the use cases there's things like optimizing the supply chain, or looking into their quality control of their products, or automating and the efficiency of their production factories, facilities. If we look at media and entertainment, that's looking much more about personalization and customer experience. Just imagine as you're going to Netflix and it's recommending the right kinds of shows for you personally based on your watching and your favorites that you've spent time engaging with. And this final graphic that I pulled out really makes it clear that the rich get richer, as is so often the truth in the world. So what we have here is the blue dots are looking at large companies with greater than 10 billion in revenues. So these are really the very largest strategic global brands out there. And the orange dots are much smaller, still enterprise companies. They've got between 500 million and $1 billion in revenue, but not at the scale of those with more than 10 billion of revenue. And here you can see, take a look at that first one. Do you describe the AI adoption in your industry as fast? Well, in those very large organizations, 86% of them would describe it as fast, whereas only 34% would describe it as fast in the smaller organizations. The rich get richer because they're moving at a faster pace. Do you expect AI efficiency gain of more than 25%? Well, much higher, 83% in the larger ones than 70%. The rich get richer. So you can see here, I'll go down to the bottom one, just as a final one there. Are you investing in generative AI? Look at the gap there. 70% of those larger organizations say yes. Only 3% of the smaller ones are. Again, the rich getting richer because they've got more money to invest, and they are investing in this forward-thinking platforms. So those were just a couple of the highlights that I pulled out of the report, but I would absolutely recommend that you get the full report yourself. It's a free download. Databricks.com, in their resources section, there's the full link which you can copy or type in and download that full report. Hope that was useful. Some really interesting insights there in how data is the foundation of any AI strategy, and AI is right at the heart of what some of these large organizations are doing, which means data is at the heart of it.